G'day team, welcome back to yet again another video on the unit circle. So now that we've learned the basics about the unit circle, we're actually going to start moving on and looking at some applications of the unit circle, looking at that periodicity and looking at our trig identities and using it to solve for trig ratios. So hopefully remembering back to that first video of the unit circle where we came up with the first trigonometric identity, cos squared theta plus sine squared theta equals 1. So I've actually written that again here. All right, super important identity that we are going to use to solve for trig ratios. So I'm going to get straight into some examples to show you actually how to do this. So find the possible values of sine theta for cos theta equals 3/4. Now, looking at a problem like this, it might seem a little bit weird what's actually happening, but remember we have this little tool up here. So, cos squared theta equals, not equals, plus sine squared theta. Now my equals 1. All right, remember this is just cos theta squared plus sine theta squared equals 1. Now, cos theta here, we actually have up here as 3/4. So we're going to substitute that in. So we've got 3/4 all squared plus, and I'm just going to write it back in this form because that's what I'm used to. All right. So we have 3/4 all squared plus sine squared theta equals 1. Now, 3/4 squared is 9/16. Plus sine squared theta equals 1. Take away 9/16 from both sides. So sine squared theta equals 7/16. All right. Now, remember how sine squared theta equals sine theta all squared. The way we get rid of a square when we're rearranging and solving linear equations and things like that, take the square root of both sides. So sine theta equals plus or minus. Super important to remember that plus or minus unless we're given specific constraints, which we'll talk about in the next example. All right, square root of 7, and the square root of 16 is actually just 4. All right, so for cosine theta equals 3/4, sine theta equals plus or minus root 7/4. Okay. Let's have another go at a different one, all right? So, if cos theta equals -2/3, and theta is in the interval pi/2 up to pi, find sine theta and tan theta, all right? Again, writing out our trig identity, cos squared theta plus sine squared theta equals 1. -2/3 for our cosine value, all squared, plus sine squared theta equals 1. 4/9 plus sine squared theta equals 1. Okay, so I've just squared my fraction. Taking that away from both sides, sine squared theta equals 1. Take away 4/9 is 5/9. All right. Now, sine theta equals plus or minus root 5/3. But remember, in the first example, we didn't have any constraints. Now we actually have some constraints. If we're looking at the quadrant pi/2 to pi radians, that means that is quadrant 2. So remember, if we're looking up here, so we've got 0, pi/2, pi, 3 pi/2. We're looking for theta in between pi and pi/2, which is, if I'm highlighting this area here. Because we're looking at sine theta, we know that's our y value. So if it's our y value needs to be in this quadrant here, we know it's above 0. So that means we reject the negative value and we're just left with root 5/3. Okay, now, so that's sine theta. Now we need to find tan theta. So tan theta remember, is sine theta on cos theta, which is equal to root 5 on 3 divided by, what's our cosine, negative 2 on 3. So what's going to happen is our 3's are going to cancel out and we're going to be left with negative root 5 over 2. All right, and there we go. So we've got our sine theta, our tan theta, and our cosine theta between pi on 2 to pi. All right. This will be how you solve most of these questions, all right, in this chapter. So please have a crack through chapter 5D. Have a go at all the questions. Challenge yourself a little bit, okay? Please keep an eye on any constraints you are given, as that will inform you on proper results, okay? Hopefully this video helped a little bit. We'll see you guys next time. Have a great day.